All right, so we're live for Ask a Physicist. Hit me with your questions. I will be taking a few viewers today as guests to answer questions, but we're going to start with questions first. Conundrum. Oh, hello. Howdy, howdy. Double slit experiment, does the observer change the result? No, insofar as you could have just as well had like a camera there. Physicist view on pantheism? Physics, if you take physics seriously, there's no room for any divine intervention. Thoughts on current fusion energy projects? I like them. I am very interested in their success. Can matter be created? Yeah, we do it all the time in particle accelerators. Can you explain the strongest argument for the multiverse? Perhaps an anthropic argument, something along the lines of along the lines of fine tuning, but I don't actually think that that's a good argument. So even camera changes result, a camera or a measuring device, anything that, any large macroscopic system that interacts with the microscopic system will do it. What do you think of first mover arguments? I'm very unconvinced. Are tachyons real? No, not in the sense of a particle that moves faster than light. However, there are things called tachyon instabilities, which the Higgs mechanism is an example of such a thing. Essentially, they are ground states for systems that are not actually the lowest energy state, and so they can kind of roll down the hill to a lower energy state. I hope I'm getting this right. It's been a long time since I've worried about tachyonic instabilities. And then you end up with a normal ground state and normal massive particles and things like that. Is time more affected by speed or gravity? They're just affected different in different amounts. Like there's not really a way to compare them, like in magnitude. So what's gravitational radiation? It's just another word for gravitational waves. So anytime that you have two things orbiting each other, the heavier and the faster they're orbiting each other, the more gravitational waves that are produced. We call that gravitational radiation because it radiates outward. Can you surf gravitational waves? No, they're much too weak. Where are the electrons? Everywhere. What's a recent scientific discovery or research you're excited about? I mean, I'm interested in the DESI results that are going to come out again in a year. They were released in April, and they will be released. There will be more results released in next April, I believe, and those will be fascinating. Can you explain how a particle accelerator works? Yeah, basically, at least at CERN, the Large Hadron Collider, essentially what they do is they take basically hydrogen. It doesn't require much. They strip it of its electrons, and then they force that hydrogen, which is now just protons, into a ring where they have essentially arrays of electromagnetic accelerators that just speed them up. And then a magnet bends them so they turn just a little bit. And then they accelerate, and then they bend, and accelerate, then they bend. And then eventually, and you do this with two separate rings going in opposite directions, and then they smash them together. And then you look what comes out. I heard that electrons can be anywhere on an atom. Yeah. Can you quickly explain single electron theory? It's not a real thing. I mean, like it was just like a vibe idea that John Wheeler had on a phone call. It's not like a real theory. So propulsion seen in UFOs mathematically and physically possible? Yeah, sure. Why do you disagree with compatibilism? It just seems like word games to me. Do you know holonomic brain theory? I don't. If you mean brain in another sense, no, but at least I can have an idea of what you're talking about. If you're talking about brain as in what's inside my head, then no, I have no idea. Why are Andromeda and Milky Way on the collision course when the universe expands at accelerated rate? Look, so the universal expansion only applies over distances large enough that the gravitational attraction is negligible. So on the scale of galactic superclusters, on the scale of millions of light years, tens of millions of light years. Andromeda is fairly close. It's gravitationally bound to the Milky Way. In fact, there's something called the local group, which has Triangulum, the Milky Way, and Andromeda as the three major galaxies, and then dozens of smaller galaxies orbiting it, which is just like a galaxy group. That's gravitationally bound together. The expansion won't do anything to that. Have you seen Bob Lazar explain how a UFO works? Bob Lazar fabricated his educational credentials. I'm not inclined to believe anything he says. Is the Big Bang an explosion in the traditional sense? No, it's not. Is the single electron theory related to tachyons in any way? No. Has the James Webb Telescope really found city lights? That's just clickbait, yeah. Sounds like I'm talking to Google. Sorry. Is math a talent or a skill that can be learned? It can absolutely be learned. Does the observer effect only apply to humans? No, it applies to any measuring device. The Big Bang myth is a fairy tale. I mean, it has a lot of evidence for it. What are Kerr black holes? Kerr black holes are really, in some sense, they are all of the black holes in the universe. They're black holes that have negligible charge, or zero charge really, and they're spinning. That's basically it. Python or Java? I mean, I use Python more frequently just because it's convenient. At what age did you get interested in physics? I was like 7 or 8 or something like that. Black holes bend light. Does reality bend, and would you bend in that gravity? All that black holes are doing is that they're changing space-time so that a straight line is what you might think of as curved. Why does the electron react differently to observer? It doesn't. It reacts differently to anything that interacts with it, because of course it does. Of course. Of course, when you interact with it, it'll change it. It'll behave differently because you're doing something to it. Does a black hole have an energy momentum tensor? No. In fact, the black holes, well, okay, it depends on which black hole you're talking about. The traditional Schwarzschild black hole has a singular energy momentum tensor at the singularity. That's one of the ways that we know it's singular. Or rather, if you tried to write down the energy momentum tensor there, you'd get infinity. But everywhere else, it's a vacuum for the Schwarzschild black hole. How close are we to quantum gravity? Seems like it's still pretty far off. Do you think dark matter could just be the universe that we call a vacuum, and it's dark matter that's expanding and somehow pushing us? So correction, just number one, it's not black matter. It's dark matter. Black matter's not a thing. It just kind of sounds racist. But more than that, no. So we can actually localize where dark matter is. We can see where it is via gravitational lensing. Why do you prefer many worlds? Many worlds is what you get when you just believe the mathematics of quantum mechanics. If you want to add on extra things, then you get Copenhagen, cubism, Bohmian mechanics, etc. Why do gravitational waves add mass to black holes? They don't. When the gravitational waves are emitted, the mass is removed from the black hole systems. If you could pick away individual atoms, would that rip the universe apart if you did? No. So black holes are the key to fast travel. That's why we have... I don't know how you got that, but no. Why do you think we are here? I don't think that there's a reason. Can you explain what tachyons are? Tachyons are like they're not a thing. But like in the 70s, maybe there was this idea that maybe there's a particle that can only move faster than light and has imaginary mass. That's not true. That there are no such things, and it brings a lot of problems with all of physics if you even imply that those things exist. So they're not a thing. But if they were a thing, they'd be like a particle that travels faster than light. What upcoming astronomical event are you most looking forward to witnessing? I heard that there was a star that's supposed to brighten in the night sky sometime this year. I don't remember why, but that's something I've been looking for. What level of computer science knowledge do you have? I mean, I'm not a computer scientist. I took some coding classes in undergrad. Are backflips or front flips easier? I don't know. Does pilot wave theory have any legs? I mean, sure, but the problem is that you'd actually have to detect, like there are potential ways to distinguish it from standard quantum mechanics, but as far as we can tell, it hasn't been done. What is a boson? Is there more than just Higgs? Yeah, a boson is any force-carrying particle. So a photon is a boson. And furthermore, there are atoms that are bosons. A boson is just anything that has an integer number of spin. So spin is this weird quantum effect, where it basically tells you about the angular momentum of the system. So for example, helium-4 is a boson, and hence it can form Bose-Einstein condensates, if I remember correctly. Thank you for the gift. By the way, y'all, like the live and consider following, subscribing. These are all good things that encourage me to do this more. I don't make a lot of money from these lives, but I do them because I think it's important for outreach. So if you like what you're seeing, consider supporting, liking the live. Get more people in here. Recent video, neutrino species, does that suggest some kind of sentience? No, species is just the word that's used for like type. Like there's electron neutrinos, muon neutrinos, and tau neutrinos. That's all I mean. Any opinion on Ray Kurzweil? I haven't thought about him in a very long time. He's a cool futurist, I guess. How do you believe life came about? You'd have to ask a biologist for that, or a chemist. Why wasn't there a live last night? I had a late meeting and then I got dinner with my wife. Why doesn't the Tipler cylinder work? Well, you need an infinite cylinder. If energy cannot be created or destroyed. Thank you for the 5 subs, TR. W for TR in the chat, y'all. If energy cannot be created or destroyed, how's the Big Bang possible in space still expanding? Energy can be created or destroyed. That's only true in a system that has time symmetry describing its Lagrangian. Our universe does not have time symmetry. So energy is absolutely being created as the universe expands. Are fields eternal? They seem to be. Is it possible in theory? Thank you for the subscription, Imro. Oh, no, that was just the one that was sent. My bad. Is it? But thank you anyway. Is it possible in theory to go to another universe like in a Penrose diagram? No, those are ideal black holes. In those cases, you're really not going to be able to make it through the Cauchy horizons. You're going to be obliterated before that happens. Do you think local realism is true? No, that was, proven false, roughly. I mean, yeah, that was roughly proven false. In a recent video, you said microseconds after the Big Bang. Is that our second or the Big? It's the same time. Time didn't run slower in the early universe. What's the difference between special and general relativity? Special relativity is when you take general relativity and you throw away gravity. Can you expand more on time symmetry? Yeah, the idea is basically like there's a certain set of equations that describe how a system evolves, and if that set of equations doesn't change, if you shifted it forward in time or shifted it backward in time, then you would have time symmetry. If quarks double when they're stretched, what happens if the universe expands enough to snap a quark? Well, that would be called the Big Rip, and we don't really know, actually. Is the speed of gravity limited by c? Yeah, absolutely. What model fit criteria do physicists use to compare models against each other? So I don't do data analysis a lot. I'm a theorist, mathematical physicist, but there are a few, and I forget what it's called, and I would love to Google it right now, because I know it has a very funny name. But there's one that's fairly common. It's someone's criterion. That's fairly common. And then also it's just a matter of looking for statistical significance to compare against the null hypothesis. That's usually what's done. Are white holes just theoretical? Yeah. Is quantum entanglement misunderstood? Probably not. Since local realism is false, does that mean FTL information transfer is possible? No. In fact, you still can't transfer information faster than light. There's something called the no communication theorem, which kind of proves that mathematically. What empirical data shows we do not have time symmetry? Well, the Lagrangian that describes our universe, this is that formula I was talking about, includes a term that corresponds to roughly the size of the universe. And that term is getting bigger because the universe is getting bigger. And we can just measure the expansion of our universe. Was there time dilation due to gravity during Big Bang when it was all dense? No. So the time dilation is a relative effect. So it only appears if there's differences in gravitational potential. But in the early universe, it was uniform. So there's no difference. You a fan of PBS Spacetime? Yes, I am. I even reached out to Matt O'Dowd to see if he wanted to collaborate, and I never heard back, which is very sad. What would it mean for a universe if white holes did exist? I don't know if it would mean that much. I mean, it'd be very interesting and very strange, but I don't think it would break the laws of physics or anything. Do you think you'd win a debate against William Lane Craig or John Lennox on the topic of God? I could at least certainly stalemate it. What's the symbol under the ask a physicist? This is a Feynman diagram. It's just 2 electrons scattering off of each other. And it's a nice physics symbolic symbol. Why is JWST in front of the sun? It's not. It's on the other side of the sun, the other side of Earth. Is all hydrogen atoms formed in the early universe, or can it be created elsewhere? Well, okay, so in principle, we can make protons. It's just really inefficient. Yeah, in principle, we can. There's no reason that we can't. We can make proton, antiproton pairs in principle, but almost, yeah, 99.99999% whatever it is of the hydrogen atoms in the universe are from the early universe. Yeah. What's the current status and your feelings on sterile neutrinos? I am not familiar with the current data on the matter. My understanding is that if there was evidence of them, I would have seen it. What's up with the preferred reference frame? Yeah, so our universe is expanding, and there is also an isotropic distribution of microwaves in our universe, the cosmic microwave background radiation. It's expanding isotropically, and so that bath of microwave photons is isotropic in a particular reference frame. If you're in any other reference frame, it'll look bluer or warmer on one side and redder or colder on the other side. So you can, but there is a single reference frame that you can pick that will make it so that it is the same temperature in all directions. What's the best argument you've heard so far for there being a god? Honestly, probably just the intuitive look at the trees. Is radiometric dating decay governed dependent on physics laws? Yeah, of course. Is the radiation from microwaves bad for you? Well, don't stick your head in a microwave, but you'll be fine otherwise. How would energy be transferred from a Dyson sphere? Well, so there was a recent test where they actually, I think that this was quite recent, where it was demonstrated that you can actually transfer energy by like microwaving, by basically sending a beam of microwaves to some receiver. So you could do that, or you could send lasers, all sorts of things. Is DNA a language? I don't think so. What happens if another Carrington event occurs in modern day? I imagine it would be bad. Is the idea of us living in a simulation just today's version of the mythology or creative beliefs? Yeah, sorta. What do you think drives planetary precession? Are you talking about how the apoapsis precesses or the periapsis precesses? There's several effects. A, we're in a many body system, and so you're going to have like Jupiter affecting the gravitational dynamics of the system. But beyond that, there's also general relativistic effects. The precession of Mercury's perihelion was predicted by Einstein and verified, actually. Or rather, was explained by Einstein. It wasn't predicted because it was observed first. What software do you use for your research? Mostly I use Maple and then a piece of software called Form, which is an old piece of particle physics software that is also really useful for tensor calculus. Does many worlds solve a lot of problems with quantum mechanics, such as perceived non-locality, non-determinism? Yep. Yes, it does. I'm going to bring up a guest. So remember, subscribers get first dibs on the guests. So, Ethan. Hey, buddy.
Hey, dude. How's it going?
Doing all right. What you got for me today?
So a bit more of a philosophical question, if that's all right. But it doesn't bleed into physics. So prefacing it by, what are your thoughts on utilitarianism? Just roughly.
It's fine.
Yeah. The reason I ask is I'm on this chapter of a book, and they're talking about how the many worlds interpretation impacts different philosophical standpoints. And
is this Sean Carroll's book, perhaps?
Yeah, I just don't like saying his name too much because I feel like anyways.
Yeah, Sean Carroll makes a good point that it shouldn't really impact your view of utilitarianism.
Well, that's where I'm kind of confused. So I get that energy-wise, you can multiply the quote-unquote branch by the amplitude of the overall function. You get energy conservation, but I'm struggling to see how the utility is not a subjective measurement. Like it can, just by branching, does that make my pain less relevant, or in the grand scheme of things? I'm wondering, does utility have something that needs to be conserved, or is it more subjective?
I don't know if you can even talk about utility as like a concrete quantity. That branches with the wave function. I think that when we start talking about utilitarianism, I think that you kind of have to. I don't think that it really interacts much with the branches of the wave function. I just don't think that that's a useful thing to conceptualize.
It definitely did seem like more of like after let's use everything we've learned to have a fun discussion, but yeah. I didn't like you just multiply the utility by the amplitude and then it ended. I mean,
that is a solution. I just think that we don't even need to worry about utility in other branches that we're not currently on.
That's a good point. Do you think it beats the branching utility monster argument where branching technically is not more utility.
So all I'm saying is just like don't worry about it. Like just like for all intents and purposes, the other worlds are like ontologically not real. Like they are there, but because they're uninteractable. Thank you for the what is this, a bouffant or something like that? Because we by definition can't interact with them, they may as well not be there.
Right. I mean, yeah, that's totally fair. I get that it's like not really useful at all. More of this kind of like a fun thought experiment. But I guess you have to really subscribe to a definite term of utility.
Yeah, and I don't know if that's a thing that can be done.
Last question is, I heard somebody describe Wheeler-DeWitt as mathematically a mess. Can you explain what they might mean by that?
I don't know why they would say that. It's actually a really nice equation. Well, okay. I mean, it is like you're differentiating with respect to metric components, which is, awful. So you're working on a space of spacetimes. So I can understand that that's a mess. But like as far as a PDE goes, it's not particularly poorly behaved.
I'll have to try to find.
I mean, it's still really, really bad.
Right.
But it's not like good luck. I would say it's probably better than the standard model.
And wait, better? Oh, you're like the giant Lagrangian on the mug.
Yeah.
Okay, gotcha. That's all I had. Thanks for having me up.
All right, take care, bud.
Dude, love you.
All right, I'm gonna answer some more questions, then I'll bring up another guest. It's a pompadour. That's what it's called. I always forget that. Is information just fancy energy? No, information is kind of like this. Yeah, it's kind of like this. It's almost a vibe. It's just the idea that a wave function should be recoverable. The original wave function should be recoverable from some later wave function. That's all. That's the idea behind information conservation. If protons don't decay, why wouldn't iron stars last forever? So there is the idea that I mean, this is a possibility that the wave function of these atoms that make up the iron stars could tunnel to a smaller size and end up with a black hole. So that could happen. Can you explain what a metric is as seen in relativity and how they relate to tensors? So the metric is just it's roughly the way of describing spacetime. And this is done by describing the space-time interval between any pair of points. And so when we say space-time interval, what that means is if you have 2 points that are different in time but in the same place, it'll tell you how long is between those two. And if you have two different places at the same time, it'll tell you how far is between those two. And so this object that tells you about these distances is independent of the coordinate choices that you use to describe your system, like whether you use polar coordinates or spherical coordinates, whatever it might be. And so because of that, it is a tensor. It's a tensorial object, meaning that it transforms nicely under GL31 or SL31, I guess, because no, GL31 is fine. Anyway, so that's all I'm saying. Could there be another spatial dimension? There could be, but it would have to be really small. Could dark matter be other worlds interacting with ours? That's not many worlds. That's a separate thing. And people have thought about this. There's something called bimetric, a bimetric model that was proposed by the same guy who proposed MOND, modified Newtonian dynamics. And other people are considering this, but it adds a lot of extra baggage that isn't needed for the standard dark matter models. So is it possible to find the other worlds in many worlds? No. So by definition, the other worlds are inaccessible. How many particles are there? I've heard there are hundreds, but the standard model shows a few. So it depends on if you're talking about fundamental particles, there's like 26 or something like that, or 25, or well, it depends on how you count them. But there's 6 quarks, 6 leptons, 5, 1, 2, 3, 4, 5 bosons. But there's also the antiparticles, and the quarks each come in 1 of 8 or 1 of 3 colors, and the gluons come in 1 of 8 colors. So 1 of 8 color anticolor pairs. So it depends on how you count them. Why aren't all celestial bodies round? Do they have to reach a certain size? Yeah, basically. They have to be big enough that their self-gravity kind of pulls them together. What else could we see aside from inverse cubed for tiny dimensions? You could see strings. That would be pretty good evidence, right? How can our universe be inside an ultramassive black hole in a greater universe? Could it be? I suppose it could be. I don't think that there's really good reason to think that there is. In 4D vector spacetime geometry, why is the time component negative? It's just a convention. You can also choose the positive convention where the spatial components are negative. The point is that there is a distinction between the two space and time. That's what makes it spacetime. Otherwise, it'd just all be space or all be time. How can particles have colors? They don't actually have colors. It's called color charge because there's 3 different types of charges for the strong nuclear force as opposed to the one type of charge for electromagnetism. For electromagnetism, there's just one charge. There's +1 and -1. But for quantum chromodynamics, the strong nuclear force, there are 3 different axes of color charge. So we call it red, green, and blue, and there's anti-red, anti-green, and anti-blue. What's the best candidate for quantum gravity? I mean, probably by consensus, it's probably string theory. I'm not sure if I'm convinced by it, but like that's probably the most popular. Do you have any original theories? Yeah, I mean, sure, but I'm not going to talk about them here because they're the subject of academic works that I'm currently working on. Is quantum superposition literal or is it metaphorical for not knowing? No, it's literal. Is it possible that there's still more undiscovered fundamental forces? Yeah, absolutely, but we haven't seen it, so. Is it possible to transfer information via neutrinos? If so, wouldn't this be the best? It would be possible, but it's very hard. So for the same reason that it's useful to transmit information via neutrinos, because they can't get blocked by anything, it's equally useful to encode information, or equally difficult to encode information in the neutrinos. Bigfoot, Loch Ness, and dragons, which is most likely to actually exist? Maybe Bigfoot? Why more matter than antimatter? I don't know. Could black holes actually be lens distortion, like a gigantic lens? No, they're black holes. They have gravity. We can measure that gravity. How does color charge show up in the stress energy tensor? In the same way that you can have gluon, all you would have to do is describe a classical field for the gluon field, which there are classical field equations. You can just punch that in the same way that you would punch in Maxwell, the Maxwell field tensor. If time were positive, we'd be moving backwards in time towards the equilibrium of 0. What? What is entropy? Entropy is in some sense a measure of disorder. More precisely, it's a measure of the number of microstates a system has that corresponds to a single macrostate. So the rough idea is for any given macroscopic object, just like, a cup of water, there's a whole bunch of different tiny microscopic configurations that the water molecules could take on to give the same information about the macroscopic system. And so entropy tells you how many different microscopic configurations there are for a single macroscopic configuration. Is going through time the equivalent of speed of light in a direction? Sort of. So we travel through time at the speed of light, if that makes sense. How can you be a physicist who studies math not recognize the math in nature? Philosophy, I guess? Do you think it's harder to prove string theory or the existence of God? Probably the existence of God. Can you explain on the theory that time is caused by quantum entanglement? Yeah, I'm not familiar with it, really. I mean, so, okay, there is the idea that it emerges from, correlations, which I suppose is quantum entanglement, and this I do have a video on. Yeah, I have a video on this, so maybe go watch this. You should probably watch that. What numbers are bigger than 700? There are none. Entropy definition with Trump voice. Is why math isn't intrinsic to nature. How much like a black hole is the universe at the start of the Big Bang? Not really at all. If anything, it's closer to a white hole. Can you break down Gauss's law for me? Yeah, Gauss's law is roughly the idea that from a given charge, you have field lines. These are kind of abstract objects. Just think of them as strings tied to your charge, and they go out in all directions. But the point is that the number of strings passing through a surface is the same so long as you're enclosing the same charge. I am accepting guesses. I'll bring up another in a little bit. Why is the unit called horsepower when a horse can produce up to 15 of that unit? I have no idea. Should we picture space-time like loaf of bread like Brian Greene says? Yeah, I like that view. How do you entangle particles? Generally, entanglement happens whenever you have a superposition that interacts with something else without breaking the superposition. Why does violating Bell inequalities in quantum entanglement in quantum mechanics is non-local? Well, it could be that it's local but non-real, right? Do you agree with my life as an RPG that light does not experience time? No, it doesn't experience anything. It doesn't have an experience. There's no reference frame, and that's his position, and it's my position. We agree on this. Would a theory of everything justify religious people saying stuff like as above, so below? No. Nothing will ever justify that phrase. Oh, did something happen? Can you guys see me? Hear me? Oh. I'm back. Okay. So subscribers get first dibs, but then there's somebody else, but no, there are no subscribers. So I'm going to bring up another guest. And Jacob, how's it going?
What's going on, man?
Excellent. So what questions you got for me?
So you're a physicist. I've seen you a few times. And you're into math. So how do you observe nature and say that, I think you had said a while ago, math is not intrinsic to nature. Can you go over that?
The way I view mathematics is that mathematics was invented to describe nature. Nature just does its own thing. We just came up with a language, mathematics, to describe it in a convenient way.
I agree with that.
That's my view anyway.
Math is a language that describes natural systems. But the question I would pose to you is, if humans disappeared tomorrow, would cells still divide following a mathematical sequence?
Well, there'd be no one to describe it mathematically.
It doesn't matter. It's like saying if a tree falls in the freaking woods and it doesn't make a sound if nobody's around to hear it. Like, it obviously does. The math is still there. We just aren't here talking about it.
I don't think that the math is there, just things happen. But this is like a philosophical position. And it's fairly common as well. It's called nominalism. So if you want to learn more about it, you can go look up nominalism if you're interested.
Well, do you think this is also why a lot of great mathematicians, physicists, geneticists, engineers who have come before you, who spent years and years in these fields, although they may not believe in specifically a certain creator, they have come to the conclusion of some form of greater intelligence behind the nature of the universe?
No, most physicists do not believe in a creator. The vast majority of cosmologists do not.
I'm not talking about physicists of today. I'm talking about the physicists who gave you the very math that you use today and get from the guys at college today. The ones who gave us these systems did believe in this stuff.
Well, I mean, you can say that if you want. I think that's probably sociological. But anyway, do you have any questions, or are you just here to debate?
I was just asking about that. So you just believe that math is not intrinsic to nature. It's just something that
I think that math is invented. I'm a nominalist. So if you want to read more about that, by all means, probably go to the Stanford Encyclopedia of Philosophy. They probably have a good article on nominalism.
Yeah, I got you. Okay, so the question then I would ask you is the mathematics that we do see, or at least have ascribed to nature, was that the cause or the effect?
I don't think that mathematics is a cause or an effect. Mathematics is a description. That would be like asking if a book describing a tree is the cause or the effect. It's neither. It's just a description.
Well, not really, because you would have to say at some point cells started to divide, think at the Big Bang, according to, the way that it's taught. At some point, in some point in space and time, things started to organize and arrange themselves in these very specific, like, for example, what we call atoms. They are described by the definition mathematically, how many protons.
They're described that way. They're not prescribed.
Well, somebody prescribed them that way because that's how they exist.
Not necessarily.
Well,
anyway,
that's what I'm saying. It's conceptual.
Today's not a debate,
mathematics.
So I'm going to let you go.
Okay.
But thanks for being here, Jacob.
All right. Good deal.
He really wanted to debate, and that's not today. Right. Let me answer some more questions, and I'll bring up another guest in, say, 10 minutes or so. By the way, I do have a Cash App in my bio. I do have a Buy Me a Coffee in my bio if the Cash App doesn't work. So that's a cool thing that you can do. People need nature sense we are, however, what day is debate day? Monday, Wednesday, or Monday, Thursday, Friday. Is it possible to fathom dimensions passing the fourth ones if they exist? Humans, as far as I know, there was maybe one human who was capable of visualizing more than 3 spatial dimensions. I think that was von Neumann. Majestic Bison, you work in industry. Yes, share the industry money, please. Yeah. Do you think consciousness is intrinsic to reality? I don't. Will you go over another physics paper in a live soon? Yeah, I just had to skip yesterday's live because of something came up. What are quantum fields? It's a good question. I mean, as far as mathematics goes, they're a type of mathematical object that has certain properties. Whether that actually corresponds to something in reality, that's a much harder question. What do you know about space weather and sunspots? I don't know much about it. I'm not a solar physicist, so do black holes ever eventually stop? They do eventually evaporate. This is Hawking radiation, but they don't like stop. They just, in fact, they very, very slowly evaporate until they're almost all gone, and then they explode. Could you provide a comprehensive description between atheist and agnostic? It's a gray area. Depends on who you ask and depends on what sense you're talking about. What are the chances of an infinite regress? I think it's possible. Do you think we could reconcile classical mechanics with quantum mechanics? There's no reconciliation that's needed. I mean, at the end of the day, quantum mechanics is what's right, and classical mechanics is just an approximation. Is the law of causality true? I'm not sure what law that is. What do you think about getting a degree in astroinformatics? I don't even know what that is, but it sounds cool. What's your favorite mathematical theory? I am quite fond of the theory of hypersurfaces. Will we be able to visually track the decay of Saturn's rings across our lifetime? I suspect not. Explain the Hawking radiation if quantum fluctuations are not true. Hawking radiation is just the idea that you have a difference of vacuum states between near a black hole and far from a black hole, and that difference in vacuum states manifests itself as a temperature difference. Is there a way to get a career in physics that isn't dependent on working in academia? Not really, no. How would you describe electricity in physics? What is the potential difference between 2 points? Electricity is just a force that is enacted on charged particles by charged particles. That's what electricity is. At least that's, yeah, in kind of like the raw sense. And the way that we describe it is with force fields. And those force fields can be described via a potential energy function, which in some sense is physical because it shows up in physical equations where the electric fields are otherwise zero. But in another sense, it's just mathematical abstraction. What does the discovery of gravitational waves mean for your field of study? It was a huge deal. It means that Einstein's right, of course. Best polymath? Maybe Leibniz? Yeah, maybe Leibniz. I have to jump down to the bottom. Is a unified field theory ever going to be possible? Maybe. I don't know. What's the difference between many worlds and the multiverse? The multiverse is like science fiction. Many worlds is just a version of quantum mechanics. Why does the bottom of a hanging slinky take so long to fall? Because even though there's gravity pulling it down, there's the rest of the slinky pulling it up. Can the Casimir effect be used to produce energy? No. Is there an intuitive explanation as to why the Planck distance is so small? Roughly, it's because gravity is really weak. The idea is that the Planck distance is the wavelength of a photon required so that the photon would have enough energy density to produce a black hole. And so you have to have an absurd amount of energy density, which means an absurdly small wavelength of a photon to produce a black hole because gravity is so weak. Were you a Christian? No. If a photon doesn't experience time, how does it redshift? The statement of photon doesn't experience time is false. There is no question about there is no answer to the question, does a photon experience time? Because it's a question that doesn't mean anything. But can the Casimir effect be used to generate energy if you squint until your head? Yeah, sure, maybe. Can we inhabit the moon's core? I have no idea, actually. I think the core is solid, so probably not. Well, I guess if you dug a cavern, I guess you could, maybe. Is eternal inflation theory true in some way? Well, we don't know. I mean, it's a hypothesis. It's an idea that we're hoping that that is one potential explanation for why the universe looks the way it does. Do singularities have a set maximum density they can achieve, or does it differ between? So there are no singularities. At least in my view, there are no singularities. There are things that a singularity in the mathematics signals a breakdown in the mathematics or a breakdown in the physics. So rather, if you find a singularity in your theory, what that really means is that there's something more complicated that we don't understand. Read my email? What email am I supposed to read? I didn't get an email. Don't tell me to read my email if I didn't get an email. Will we ever be able to use black holes for speed travel? No. Oh, by the way, also, I can't use my computer right now because my computer is currently recording this live stream. So if you tell me to read my email, I won't be able to. But if you sent me a gift, thank you. Can you explain wave-particle duality? There isn't one. And this is a controversial take, but wave-particle duality is just what happens when you have people who want to think of particles and then they run into quantum mechanics. But really, it's just all waves. It's waves all the way down. Are you a physicist by any chance? Yes. Yes, I am. Yes, I am. Do you believe in the singularity future? Oh, that singularity. Oh, yeah, maybe. Have you read A Brief History of Time? A very long time ago. But if I remember correctly, it was very good. Can you explain how the age of the universe is calculated? And did the JW telescope change the calc? No. So the James Webb didn't change anything about the age of the universe. The way that the universe, well, there are a whole bunch of different ways that we can calculate the age of the universe. But roughly what we can do is we can measure the density of the universe. We can measure like how much matter there is, including dark matter. We can measure the expansion rate of the universe, which informs on roughly dark energy. And we can measure the radiation of the universe, which is roughly negligible here. And then you can plug those parameters into a simple cosmological model, wind the clock back, and it'll tell you. And once your model tells you that it gets down to zero size, a singularity, that's an age of the universe. Now, of course, you can get more accurate numbers by doing more complicated things, but that's the rough idea. Would the universe destroy itself before a supermassive black hole evaporated from Hawking radiation? I don't know what you mean by destroy itself. Thoughts on the big bounce? I like it. I like the idea of a big bounce. Is the surface of a neutron star solid? I think it's at the point where like those notions of phase don't actually make a whole lot of sense. Does space-time have surface tension similar to water? Well, it doesn't have surface tension. What it does have is it does have like a Young's modulus, which is so it's very, very stiff. What was your PhD about? My PhD was about conformal hypersurface geometry. Thoughts on how to improve science communication to the lay public? Stop lying. Like stop oversimplifying things. Trust the public that they'll understand. Do gas giants have compressed solids at the center from gravity? I think that's one of that's an idea, but are there massless particles? Yes, absolutely there are. Photons, for example. How does a rocket work in a vacuum? Well, the same way that a gun has recoil. A gun has recoil because it pushes stuff out one end, so it feels a force back in the other direction. A rocket is basically just shoving stuff out the back, so you feel a force pushing you forward. Have you ever been an instructor professor? I have. Yeah, I was an instructor for a few years while I was in grad school. Currently, I'm in a pure research position. Maybe when I go back to the States, I will be in a teaching position. We'll see. Photon is not a particle, though? Well, it's a particle in the sense that it's a fundamental excitation of a quantum field. Could gravity ever be theoretically manipulated by technological means? We can do it now. I'm manipulating gravity right now just by moving my water bottle around. Why do you think string theory is worth considering? Because we've learned a lot about the universe, about like quantum gravity in general, just from studying string theory. And the reason why is because even if string theory isn't the correct quantum theory of gravity in our universe, it is a consistent theory of quantum gravity, which means that even if it doesn't describe our universe, it will describe quantum gravity in some hypothetical universe. And so we can learn like qualitatively what quantum gravity is like by studying string theory. What is nonlinear quantum mechanics? It's when your Schrodinger equation has nonlinearity, isn't it? Which is really messy, like really, really messy. If a cat meows, does that mean Schrodinger's cat is flawed, or is the meow the observation? It depends. But essentially, any interaction with the environment is the observation. Which unifies quantum mechanics or relativity better, loop quantum gravity or string theory? Better? I mean, depends on who you ask, right? When's your beta when we'll have a stable 1,000 qubit computer? I have no idea. How much to teach me quantum electrodynamics? $45K a year? How would light propulsion cells work if photons have no mass? Well, they still have momentum, they just don't have mass. You don't know anything about the world except what propagandists indoctrinated you with. Oh, okay. Good to know. Is pilot wave theory dead? It's not dead, it's just not very popular. Have you ever met a super genius you couldn't keep up with intellectually? No, but only because those kinds of people who are successful in the field tend to be very, very, very capable of communicating. And so, like, you're not gonna run into people who are like physics and mathematics is collaborative, right? So, like, you're not gonna get very far if you can't communicate your ideas well. Do I need a license to launch small-scale hobby rockets? I have no idea, actually. Are you afraid you won't be able to keep up with the paradigm shift one day? No, I'm not that worried about it. As light from a star spreads out and weakens, do gaps form between the photons? Photons are not just little packets, like, okay. I get this question literally every time I do a live. Photons are waves, and waves can be spherical. That's the answer. They're not like little things emitted at different, like, that's just not how it is. How's a photon momentum calculated? It's related to its frequency, higher frequency. It's momentum. So it's okay. So energy is momentum time. Sorry, energy is frequency times Planck's constant. Momentum is energy divided by the speed of light. Can you slow down a photon without absorption or re-emission? No, not really. But again, when you have interacting systems, it's not really useful to talk about photons as photons. They're more complicated excitations. Most of the 99th percentile cannot effectively communicate with people around them. Then they wouldn't be successful in this field, so I wouldn't have run into them. Do you think intelligence is something you can increase, or are some people limited? I mean, there are certainly genetic components. However, absolutely, most people are not functioning at their upper limit, right? What is vacuum self-polarization in the context of real bare photons? Vacuum self-polarization. So a photon is propagating, it can, yeah, okay. So a vacuum is propagating and it can interact with the electron field, for example, and the electron field can polarize the vacuum. So you can have self-polarization, I guess, in that sense. The flower of life is not a real thing. All right, I'm going to bring up another guest. Again, subscribers get first dibs. So, but there are no subscribers, so I'll bring up Peter. Hey, how's it going?
Good. How are you?
What you got for me?
I
good, by the
just
way.
watched a video on the YouTube channel Kurtzgesagt. Are you familiar with them at all?
Yeah, they're good. Generally.
They mentioned tachyons, and I thought that was pretty cool. And they mentioned that things like have basically a constant vector or a constant velocity through space-time. So that was basically a way of explaining time dilation.
Yep.
And they showed like a diagram where it was like spatial speed on the horizontal axis and temporal speed on the vertical axis, and it looked kind of like a circle. So their vector, if they moved, if they increased the spatial component, it would decrease the time component because it was following the circle, right?
Sure.
And then they mentioned tachyons, where they said, if you go superluminal, then it requires a negative time component. And at that point, my brain kind of broke, and I was like, okay, so how would you extend this graph from the semicircle that they showed?
It becomes a hyperbola.
Does it? Okay.
Yep.
That is so interesting. Okay. So is the semicircle on the top just like a portion of that hyperbola?
No, so the reason anytime that you have, if you want to go faster than light, you need imaginary mass. The circle is in some sense describing real mass, like the motion of real mass things. And so if you take a circle and you replace and you kind of complexify it, essentially, if you take a circle and you replace your mass with like imaginary mass, it just flips one of the signs and you end up with a hyperbolic function.
Oh, okay.
So like basically, there's another way to visualize this, which is an energy versus momentum plot. And so your energy in some sense is always bigger than your momentum in some, there's some useful way of describing that. However, if your mass is imaginary, then it could actually be less, and so you end up on another branch, and in this case, it's a hyperbola.
Okay. Well, I guess that helps. Thank you very much. I'll probably let the next guest on.
All right, take care. Talk later.
Yep.
Have you heard of mathematical anomalism? Yes, that's me. Nice to meet you. Is this more analytical continuation abuse? Yes. Tachyons aren't real, everybody. What will happen? Will we ever understand why the Big Bang happened? Potentially, yeah. Isn't gravitational redshift slowing down a photon in a way by altering its wavelength? It's not slowing it down, it's just changing the wavelength. Do we think we will ever know what the meaning creator of our universe is? I don't think so, because I don't think there is one. Are you an atheist? Yes. Who invented triangles? I believe his name was Pythagoras. Do you think Oppenheimer was planning on having regrets but built the bomb anyway for notoriety? I don't know. Do all mathematical equations and proofs have a real-life application? No. What's the point? It's fun. Is time travel possible? Probably not. Quantum computer algorithms solve unique problems, but can quantum computers do everything someday? No, I mean, there are some things that, some problems that quantum computers aren't faster at. How sane is a physicist? You think profession comes with a... I don't know what that means. It was actually John Triangle when he tried to turn thrice true. What is the simplest way to experimentally entangle two photons? Get a crystal that does spontaneous parametric down, or is it spontaneous parametric down conversion, where it takes one photon and it splits into two, because then those two photons are entangled. You can actually find, I think that this works in reverse. If you take a green laser pointer, like one of the old ones, there's a crystal in there. I think it's called YBO. Yttrium barium oxide, maybe, which is a frequency doubler. However, if you instead shine a green laser through it, it'll split it into two infrared photons. I think that'll work in reverse. Yeah, it's SPDC, by the way, spontaneous parametric down conversion. What's the simplest explanation of quantum physics? That quantum systems are vectors in a Hilbert space. Academically, did you ever struggle ever and during getting your PhD? Not in, well, okay, there were some classes that were hard, but I didn't end up using them. And writing up the actual dissertation was very stressful, certainly. I started drinking, I drank coffee when I was 18 years old, and I stopped until I was 29 or 28 when I was writing my dissertation. So, you know, got me to drink coffee again, I guess. You're giving a talk on superconductors tomorrow? Good luck. What speed do you think we would need to travel to beat and teleport? I don't know what that means. Is there an intuition why physics laws exist, or just that they do exist? Look, so I think that physics laws are descriptions. So like we see stuff that happens in the world, and so we come up with a way to describe them that seems to always be true. Should I do physics or engineering degree? I like physics more, but that's up to you. Thoughts on Wittgenstein's work, The Philosopher? I haven't read it, so I don't have a lot of time to read philosophy. I read physics. Gravity is and mathematics. If gravity is bending of space-time due to mass, why do some theories require gravitons? It's just another description. They're not required. You can have a fully classical theory of gravity that doesn't have gravitons. But if you want a quantum theory of gravity, then the classical theory of gravity is kind of like a zoomed-out version of gravitons doing graviton things. Does time travel violate any known laws of physics? Yes. It breaks unitarity. It violates relativity. Probably doesn't go against the second law of thermodynamics, but do you remember to take your meds? If so, how? Most days I do. And it's because I have a routine. What was your dissertation on? Conformal hypersurface geometry. Do you think gravitons exist? I mean, yeah, in some sense they kind of must. Have we figured out how supermassive black holes formed? We haven't figured it out, but we have a good idea that they were formed via direct collapse in the early universe. What's more feasible within the next 50 years, interstellar travel or teleportation? Interstellar travel, easily. I don't think that teleportation is real. Do you know Steve Mould? Not personally, but I like stuff. Yeah, forward time travel is fine. Any tips for an aspiring physicist? Go to school, get good grades. Unfortunately, it's the most boring. Who's currently the smartest physicist in your opinion? Smartest? I mean, the easy answer out is Ed Witten. Ed Witten is brainiac. Do you believe in simulation theory? No, that's religion for tech bros. Could we use sound frequencies to heal? Not really, not in like any sort of mystical way. Do black holes merge to create them? No, it's probably direct collapse, potentially involving dark matter. Do you think we have free will? No, not really. How do I feel about it? However, I have to. Why do forces need a particle to carry them? They don't. You can have classical forces. It's just the quantum description of forces involves an excitation. How close are we to understanding what dark matter is made out of? Look, we have like 100 different ideas as to what it might be. We just need experimental evidence, right? What are some maybe not conventionally talked about ways of collapsing a quantum system? Any interaction with a macroscopic system will do it. Are set values physics or I don't know what you mean by set values. Today is not a debate live AL51, so not today. Eric Weinstein is afraid of Ed Witten. He should be. All right, remember, subscribers get first dibs. We have a bunch of guests, so I'm going to bring up Alex first, and then we'll bring up another guest afterwards. Alex, how's it going?
Hey, good morning. How are you?
I'm doing all right. What questions you got for me?
I got one really simple one, and then one that I don't know if it actually fits your life. But the simple one is, do you have any like physics problems or math problems that just like you feel like we should be able to solve, and you're like, what? Like, what's the missing link? I just kind of wonder what keeps you up at night in the math and physics world.
Honestly, no. For most of the open questions that I'm interested in, I know why they're hard, and I know why they haven't been solved. Not that I know the answer, but rather I know why they're hard.
Yeah, that makes sense. You're highly educated. Second one is, what do you think is the most complex structure in the universe that you've observed through your studies?
Complex structure in the universe?
Yeah, I mean, I hear you on debates all the time.
Colliding black holes. It's easily colliding black holes. Colliding black holes are so complicated.
Cool. I'm gonna have to go read about that because that sounds interesting.
It's just the math is so hairy.
But have we observed them? Like, is that a thing we know exists?
Yeah.
Okay.
Yeah. We've observed, 50 or something in the last. The first one was observed, I think, in 2017.
Oh, so it's happening a lot.
Yeah.
Cool. Well, thanks. I enjoy your lives, and when I got the excuse to subscribe to skip to the front of the line, I had to do it. So thanks for having me.
Fair enough. All right, well, take care. All right, I'm going to bring up Avery because we have another subscriber in the box. So Avery, come on up.
Hi. All right, I subscribed just to pick your brain on some ponderances, right? So a little background on me.
Sweet.
I used to work with chemical weapons in the military. I'm autistic and I burnt myself out severely, but I used to be a math savant, like doing calculus in my head type shit. Can't do it no more, but I have some ponderances about space-time.
Okay, sure.
So if we were to look at time travel but disconnect it from space, so we don't end up a billion miles back away from the Great Attractor, how would we get the universe to understand what we're trying to do and not blow up or shrink our particles in, you know, like, you know, how, like, when we get the universe constantly expanding, the space in between atoms, in between subatomic particles, and the subatomic particles themselves are constantly expanding at
No,
a
those are
very
staying the
slow
same.
rate.
No, those are staying the same.
Those
The
are
only
staying the
space that's
same?
the only space that's expanding is the space between galaxy clusters.
So
There
we're
is
not
no
going to
expansion.
explode up into a giant Ant-Man if
No.
we learn how to time travel.
No.
Okay, that's some worry off my chest.
Well, I'm
right?
glad. I'm glad I could resolve that for you.
All right, thank you. I've been panicking about that. Like oh no, they're gonna figure
Time
it
travel's
out, and
also
then there's gonna
probably
be
not very likely.
giants.
You're good. You're good.
Okay, no giants, no giant Ant-Mans running around.
No giant Ant-Mans. We're good.
Okay, cool.
All right. Anything else?
Have a good one.
All right. Take care. Do we have any other subscribers in the guest box? All right, then I'm going to add. Oh, we do. We have one other subscriber in the guest box. Hey, how's it going? C-Bar? You there?
Dude, I did not mean to join. I am sorry.
You're
Can you
good.
drop me down?
Yeah, I got you.
Yeah, thank you very much.
All right, I'm going to answer the chat for 10 or 15 minutes, and then I'll bring up another guest. And again, subscription gets you to the front of the line. Can we theoretically compress dark matter? We don't have a way to manipulate dark matter as it stands, except by, I suppose, gravitationally. So no, I mean, so theoretically, sure, but we don't have a way to do it. What's a popular theory you disagree with and an unpopular one you do agree with? Popular theory I disagree with is the Copenhagen interpretation of quantum mechanics. That's kind of like the orthodox quantum mechanics, the one with collapsing wave functions. I don't think that's right. And then an unpopular one I do agree with is I think that a big bounce is plausible. And I think that there could be a recollapse in the future. If you could have the absolute answer to one question, what question would it be? You know, my original answer to that question would have been quantum gravity. However, Ibrahim gave me this brilliant idea for an answer to that question, which is, what is the fundamental stuff that makes up reality? That would be a really good question, I think. A really good question to the answer about. How do we know that exactly the speed of light is the max? Well, I mean, according to relativity, the speed of light, or this max speed limit, is just how fast massless things go. And we know that they're massless things, so we can measure how fast they go. Do you think current theories like string theory give us better insight? Yes. What do you think about loop quantum gravity? I like it. I don't know if it's right, but I like it. I like it quite a lot. Are you afraid of death? I mean, the way we would lose our consciousness? I'm too young to be afraid of death. I try not to think about it. Do you believe in anything supernatural? No. Can you explain what is the difference between spin, isospin, and third projection of isospin? Okay, so spin and so the third projection of isospin is just a component of isospin. So don't worry about that. Spin or isospin is just roughly, it's like charge, but for the weak nuclear force, roughly. And the reason it's called isospin is because it has similar algebraic structure to like regular spin, like angular momentum spin. So that's why it's called that. Because they didn't know what it was at first. What is the second quantization about? Well, first you quantize once, and then you quantize. No, but really, the second quantization is just what happens when you let when you move from single particle quantum mechanics to field theory quantum mechanics. Matter Dad made fun of Eve players in his last video. Beautiful. How would we be able to build warp drives? There's a whole cottage industry in the mathematics of warp drives. The point is that they all require exotic matter, unless you're going slower than the speed of light, and then they don't require exotic matter. Does cubism prove FH? I don't know what FH is. Charge is just poor man's angular momentum. No, isospin is just poor man's angular momentum. Do you think thermonuclear fusion energy is a field worth working on? Yeah, absolutely. I mean, I don't like, I can't work on it. It's not my field. I don't have the expertise, so I wouldn't be able to get a job doing that. But I think that it is very valuable, and I praise people who are working on it. In case of a big bounce, do you think there is a possibility of the universe event repeating exactly? I think so, yeah. What's the most difficult class you took? Probably topological quantum field theory, because I just didn't understand it. How do you know light contains information? What happens to the info when light hits an object? Contains information is like it's a weird statement. Like, the state of a photon, for example, has like we describe the state of a photon with information. And when that photon is absorbed, that state changes and impacts the state description of some other stuff. So it's conserved. Can dark matter be antimatter? No. No, we can see antimatter. Why aren't you working on physics? It's 8:45 in the evening. Do you think gravity is emergent? Possibly, yeah. Should the US government hire you to reverse engineer UFOs? Would you want to? If they were real, absolutely, that would be cool as hell. I don't think they're real, though. You ever game? Yeah, I haven't gamed in a while. I've been playing. I used to play a lot of Baldur's Gate. I would play Overwatch sometimes with friends. I've been playing AoE4 with a friend on here lately, but I've just been really busy. Can you promote why anybody should learn physics? Because if you want to learn how the universe works, physics is the way to do it. Is matter's existence infinite based on the second law of thermodynamics? No. We make matter, new matter, and destroy matter all the time. Should we worry about the magnetic poles shifting? No, unless you're like a navigator on a sailing ship. Likelihood the Big Bang happened multiple times? Well, if it's a cycle, then it's happened forever. What do you main in Overwatch? Widowmaker and May. Because I'm a degenerate. I'm a degen. Do you watch Star Talk? Not often. How can we understand what happens at a black hole center where physics seems to break down? Well, we need a theory of quantum gravity. We just don't have it. There was a particle with negative mass, would it necessarily mean it would go faster than light? No. Actually, no. You need imaginary mass for that. Why does it seem like there's not a lot of money in science communication? Because there isn't. It's a pretty saturated field. There's like Neil deGrasse Tyson. There's Hank Green. That's like it, right? There's like other people, but they're not nearly as popular. How's the cost of living where you are compared to us? It's about half as much as like California, not like Bay Area California, but just like near Sacramento. It's like half as much as that. Neil deGreen Hanks. Is it reasonable to pursue a Phys MS PhD as a math BS student focusing on topology? Sure, you could easily be a string theorist if you have a focus in topology. How does the whole time crystals thing work? How can time form structures? I'm going to make a video on this at some point. Do I know Hebrew? I know enough to read that. Let's put it that way. I took 6 years of Hebrew, but I retained very, very little of it. Advice on choosing a PhD if you have multiple interests. In my opinion, choose the PhD that has an advisor associated with it that you are most interested in. Or not that you're most interested in, that you get along best with. Do you work at CERN? I do not. How many Discord Smackdown summons do I get a week? I don't know what that means. Neil DeBaltine. Yeah, the time crystal video has been on my to-do list for like a year, and I just have been putting it off. What's your favorite unit in physics? I like the Henry, just because it's fun to say. I have not read Physics of the Impossible, no. Is space-time at the Planck scale a manifestation of non-commutative quantum algebra? Possibly. Oh shit, there's a whole goddamn yeah, Luja. Yeah, no. I know some of those words. How many scientific papers have you published? 8, which will be 10 soon. So sorry. I don't know. It's somewhere like the 8 to 10 regime. Yeah, also, don't pick a supervisor approaching retirement. You don't want a super young supervisor. You don't want a super old supervisor. My supervisor was in his 50s, I want to say. I think he is nearly 60, or maybe 55. I think he was in his early 50s when I started with him. And that's like the perfect age because he's experienced enough. He's had students before. I'm not his first student, but he also still cares he's not near retirement. So definitely important too. Where are the famous scientists apart from you? Where are Newtons and Einsteins? There are plenty of famous scientists. You just don't know them. So maybe they're not that famous. I have not read a book by Stuart Clark, no. Why does gravity slow time? Well, gravity is the curvature of space-time, and if you curve space-time, then you're curving space too. Is there patenting in physics? Not really, no. If Joe Rogan invited me on to like debate him, I probably would. Yeah, the Feynman lecture physics books are very good. Does the standard model of particle physics also apply to the antimatter side? Yes, it describes antimatter as well. Which physics field would you suggest going into, job opportunities aside? Whatever you find interesting. I mean, I find relativity fascinating, and so I ended up doing differential geometry as it applies to relativity. I'm a classical physicist at heart, by the way. Like, I will do quantum mechanics if I have to. I will do quantum field theory if I have to, but I'm a classical physicist at heart. I love me some relativity. Can dark matter be a matter that is stuck in another dimension? I mean, in principle, I suppose it could be, but we don't have any reason to think so, and that would make a really complicated theory. What's a great textbook for general relativity? A great intro textbook, and I like this, there's a soft spot in my heart for this book, is Sean Carroll's Space-Time and Geometry. That's what I learned relativity out of. There are other better textbooks in that they go into more depth and are more rigorous, but Space-Time and Geometry is really excellent for getting like, it will get you up to speed on differential geometry, it'll get you up to speed on topology you need to know, and you'll learn everything that you need to know to get started in GR. Yeah, I mean, there's gravitation by Thorne, certainly, but like if we're talking about like getting an intro, I don't think that gravitation is the best place to do it. I mean, like there's also like there's Wald as well, but Wald is like, some would say Wald is a terrible book. I use Wald as a good reference, but like it's not a book that you start with. The textbook is at like an early graduate level textbook or level. It just requires a level of sophistication. You could certainly do it at an undergraduate level, though. At like the advanced undergraduate level, you could definitely do it. That's what I did. But I think it's designed for like first year grad students. Could gravity actually be acceleration in some kind of weird inside-out way? I don't know what that would mean. Gravity by Hartle was a terrible first time. Yeah, I believe that. What are the materials for the rovers that made it cost $38 million in 1969? Well, it's not just materials, Jim. You know this. It's also labor. It's the technology included. It's not just like raw materials, buddy. Could our universe be in a superposition? I expect it is. Can you explain Noether's theorem and how breaking symmetries gives rise to particles? That's like a word theory, like a word identity thing. No, I can't. I can explain Noether's theorem, but not the quantum field side. Roughly, Noether's theorem is, I mean, without going to the mathematics, because it's just a mathematical statement. Noether's theorem states that if there's a symmetry of a Lagrangian, there's a corresponding charge associated with that symmetry, a continuous symmetry of the Lagrangian anyway. So this is how you get conserved quantities, like a conservation of energy, conservation of momentum, and things like that. Could dark matter ever accumulate as a large sphere or planet? It doesn't interact enough to do that. It would take a very, very long time. If energy can't be created and destroyed, where does gravity take it from to attract things? Energy can be created or destroyed, but gravity doesn't require that in order to attract things. Gravity, there is energy associated with gravity, and that energy is bigger if you're further away and smaller if you're closer. How often does mathematical physics translate to applied? Not often. If time isn't real, then why is it involved in physics? Who says time isn't real? Did you say space-time bends? Absolutely, it bends. Yeah. What happens when quantum mechanics and general relativity clash at the edge of the black hole? They don't clash at the edge of the black hole. They clash at the core of a black hole. That's the problem. I'm going to bring up a guest. We have no subscribers in the guest box, so I will just bring up the first guest. Jesse. All right, Jesse's not connecting, that's fine. Yeah, energy is created in our universe because the universe is expanding. Why is your universe mostly matter, not antimatter? Good question. I don't know. Carson, I already answered your question. If electrons are all negative, then why do chemical bonds even exist? Because protons are positive. Can a new Big Bang start after the heat death? I suspect not, but Penrose disagrees. I'll be working with my physics homework. By the way, y'all, I am going to an invite-only conference in December. Big deal. Me. And it's in Canada. So that'll be fun. Yeah, Carson, so I disagree with the Copenhagen interpretation, which is the common understanding of quantum mechanics, and I think that the Big Bounce hypothesis is a good cosmological model. I'm going to see if I can present. I hope I'm presenting, but I'll need to see if I can. Yeah, it'll be. I don't want to give. I don't want to give away where it'll be, because then somebody might be weird about it. But I'll definitely do a live from there. I'll do a few because it's a week. Do you think Hubble tension is caused by unknown physics or a standard candle mismeasurement? I suspect the standard candle mismeasurement. Are you an Everettian guy? I am. I'm in Toronto. Have you been to Canada before? I have been to Canada, but it's not in a city. I'll give you one hint as to where it is. It's not in a city. M theory still a thing? Yeah. What exactly is information? As info cannot be created or destroyed. Information is just like, roughly, it's the quantum state. It's like a mathematical description of the quantum state. No, we're not grabbing a Canadian beer. Sorry. It's not in the ocean. It's not in the city. It's not in the ocean. No more details, though. Which topic are you most interested in right now and why? Right now, I'm just doing a lot of conformal geometry. But that's because that's what I'm an expert in. It's like what I did my dissertation on, and I'm like probably one of top 20 most knowledgeable people on this particular topic in the world. So it's probably true. Which is weird to think about, but it's also a very, very niche field, right? Does that mean energy is part of a cycle? It does bother me that there's no start to a cycle. Yeah. Are there any German theoretical physicists from a certain era, questionable era, whose theories are accepted? Einstein was from that era. Einstein was German. Don't you know? Is gluon even real? Yeah, in some sense it is. Was there anything you learned in school that put you in existential crisis mode? No. The universe expands faster than light, but going faster than light means going back in time. No, so that's only moving through space faster than light, but the universe can expand at whatever speed it wants to. 5 reasons why you should study physics at university. Oh, the only reason you should is if you're interested in it. Why are you so interested in geometry? Because it's so nice. I can't explain it. It's just so nice. Is geometry sacred? No. It's just nice. How can you become better at physics? Do your homework. Fan of philosophy? Yeah, that's cool. It's a good idea. Is it conceivable that one day an artificial magnetic sphere could be placed around Mars? Artificial magnetic sphere, I don't even know what that means. Yeah, maybe though. If you mean like an artificial magnetic field, yeah, that's possible. What challenges remain in unifying general relativity with quantum mechanics? All of the challenges that existed 70 years ago are still there. It's actually a math conference. Would you like a DSC? It's not a thing in my field, really. Nobody really worries about that. Is it true that the more mass I have, the heavier I pull maidens? Yes, that is true. If you take a light year long pole and turn it 360, wouldn't the tip move faster than the speed of light? Yes, if you could turn it that fast, but you can't because there are no rigid objects in special relativity. Fan of ADS3 CFT2? No, it's only 3 dimensions. You need more dimensions than that. Is time a particle? No. Do you think AI will come from physicist or mathematician jobs eventually? Yeah, probably. Why do all shapes fit in a square hole? Because all of the shapes are small. Taking Physics 1, do you have any tips on how to study it? Any techniques that personally helped you? Well, make sure that your math skills are up to par, because you really don't want to be struggling with mathematics when you're trying to learn physics. That's going to be your first it's going to be your first mistake. And honestly, of the students, so I taught Physics 1 a lot when I was a grad student. And the students that struggled the most were the students who were struggling with the mathematics before they could even learn the physics. So if you get your mathematical fundamentals down, you'll have a much easier time. What is the Hawking radiation of a black hole? Roughly, it's that the area around the black hole event horizon is slightly warmer than empty space. And so energy flows from hot to cold, so you get Hawking radiation. Is there a fundamental unit of time? Yeah, we call it the second. ADS3CFT2 is nice, I agree. I don't think it's rigorously proven. But it is quite nice, I agree. But the gravity on that side is just very boring. Do you breathe in or out or hold your breath when drinking? I don't know. I mean, like an indivisible unit of time. No, there's no reason to think that such a thing exists. Does time have mass? No. No. Why does the event horizon stop and doesn't keep expanding? Why would it keep expanding? The event horizon is just the area beyond which gravity is too strong for light to escape. What math knowledge should I have when starting quantum? You should know linear algebra and differential equations. Do you think cosmic strings exist? I hope so. That would be fascinating. Do you think the codes on the Voyager gold record would be different if sent today? Yeah, probably. Someone told me photons have mass, and then he read it in classified patents and blocked me. Well, he lied to you. If the universe is infinite, then how could the universe be expanding? Expansion is a local phenomenon, so it doesn't really care what the size of the universe is. It just says that if you put 8 ping pong balls in space to form a cube, and then you wait 10 billion years, those ping pong balls that cube will be twice as big, or rather it'll be 8 times as much volume in that cube. That's all. Being a physicist seems too easy and boring. What's the most challenging subjects within physics? Seems too easy? Okay. I don't know how to answer that question then. Does long exposure to high magnetic fields affect the body? I don't think so. Is it theoretically possible that, according to quantum physics, that a fluid can pass glass? I don't know what that means. Is the photons trapped in a box description accurate for mass from energy? Yeah. How many rotations of the Earth is required to produce the next Einstein? Who knows? They might already be alive. We can measure the size of the universe. Why can't we locate the center? Well, we can't measure the size of the universe. We can only measure the size of the observable universe. And we're at the center of the observable universe because it is the sphere around which light has had time to get to us. What do I do if linear algebra sucks? Get good. That's what you do. Can you explain how a cycle doesn't have a start? Well, where's the start of a circle? Do you agree that Ed Witten is the smartest human alive right now? Maybe not the smartest human alive, but probably the best physicist. Or the smartest physicist, maybe. Are there very many physics jobs opportunities outside of academia? No. Any good online resources to help people grow their knowledge of theoretical physics? My channel, PBS Spacetime. Those are probably, in my opinion. And then there's like a smattering of websites. And of course, reading academic articles would help. But yeah, a lot of the science channels don't do a whole lot of theory. So, is there a truly massless particle? Yeah, photons. Photons, gluons are both massless. Do you think that you're smarter than the PBS Spacetime guy? I don't. Look, my only interaction with him is through his videos, and his videos are excellent. So if his videos are an indicator of his intelligence, no, he's way smarter than me. But I don't know about his research. I don't know who he is as a person. I'd love to meet him and get a beer with him or something. That'd be awesome. He seems like a chill dude, but he also seems busy. So as a physicist, you get to work with any equipment. I don't, but that's because I'm a theorist, right? The only equipment I get is a computer, a pencil, and some paper. Would you ever do a live panel like this in the US? Yeah, I'd be happy to. Let's say look straight up into the universe. Wouldn't your view eventually get blocked? Only if the universe was infinitely old, but it's not. At least not in the current phase. Couldn't a physicist always start a TikTok as a career path? in principle, but it's not super profitable. Have you read the paper that suggests warp drives might not require exotic energy? I have, and I made a debunk video of it. Transgender? Who? Me? That's sweet, but no. As a physicist, have you worked on the healthcare side? No. Space-time expanding, is it stretching like thinning, or is it growing more of itself? There's not really a way to like differentiate those two. There's just more volume. A volume becomes a bigger volume, right? Why does a photon have momentum? I mean, it does based off of the mathematics. It carries energy across distance, so it has momentum, I guess. Like that's one way to think about it. Do you think non-computable phenomena have a legitimate place in physics? I don't know, maybe. It's possible to learn physics at 46 without going back to university, and if so, how? You're going to want to pick up textbooks. Is Neil deGrasse Tyson a tool? I've never met the man in person. He seems like he's a chill dude. But I also have heard that there were weird allegations, so I don't know. I don't know anything about him personally. I did have my wife read his book, Astrophysics for Someone in a Hurry, and I thought that book was really good. Would you become a transhumanist? Yeah. Energy with no mass? Yeah. Faraday or Maxwell? They're both great in different scenarios. Thank you for the subscription. Based and subscriber pill. By the way, y'all, I do have a Cash App in my bio. I also have a Buy Me a Coffee in my bio if you're interested in supporting me in any way. Those are cool things to do. I also have a Patreon, but I don't post anything there. It's just if you want a subscription that doesn't go through TikTok. And I think, Jerry, did you just subscribe so you can ask a question? Because if you did, that's based. Yes, you did. You absolutely did. Jerry, how's it going?
Pretty good. First, I want to tell you thank you for this channel. Seriously, I don't think people understand how rare it is to get to pick a brain of someone like you. You're a theorist, which is specifically why I wanted to talk to you. I sent you a link of something I've been working on for 15 years, and what I sent you was
a lot.
I mean, yeah. So I'm like vacuum energy. General relativity says that at the base it's repulsive. So my theory is that the natural state of the universe is dark, cold, and repulsive. So in that way, it attempts to identify the anti of gravity, just like the other three fundamental forces, as inverse gravity. That's why I think that the universe can be expanding faster than light without destroying all mass. What do you think?
Well, it's not expanding faster than the speed of light. It's not expanding at a speed, right? And this is a common misconception. The expansion of the universe is not something that has like a miles per hour. It has a doubling time, right? So the best way to think about the rate at which the universe is expanding is that it roughly doubles in size every 10 billion years. Now, if you're talking about a region of space that is more than 10 billion light years across, then yes, in some sense, it will, like the outer edges will move away from each other at faster than the speed of light. But that's not really like a useful measure because it just depends on how big of a volume you're looking at.
Right.
Now, as far as vacuum being repulsive, that is true if you neglect gravitational self-energy. And there's some recent work on that by myself and some other people, which, you know, calls into question this whole notion that actually the vacuum energy is driving expansion at all. I suspect it's not.
The vacuum catastrophe.
Well, yeah. So, I mean, the point is that the gravitational self-energy is sufficiently strong to kind of wash out any, like the 10 to the 120 or so.
120, yeah, orders of magnitude.
Yeah, the gravitational self-energy is enough to make that negligible, actually. So
it could cancel itself out.
Well, but the point is that even if it doesn't, it's negligible anyway, so it doesn't really matter. It's negligible compared to the gravitational self-energy at the Planck scale. So I suspect that it probably, I mean, this is speculative stuff, or at least, you know, it's cutting edge stuff. So it's really hard to say whether or not my conjecture about this is true. But it is certainly an idea.
Has anyone looked into the possibility of like what we identify as dark energy being the opposing force of gravity? Because gravity attracts.
That's what it is. That's like the modern understanding of it.
Yeah. So would that be called inverse gravity? Is that the best?
No, we just call it. I mean, gravity is just what happens when space-time isn't flat. And so dark energy is just a manifestation of that. It's just another type of gravity. It's just this gravity happens to be repulsive. There's also other examples of repulsive gravity. Near the poles of a spinning black hole, there's also repulsive gravity, which is very weird.
It is. But is it, I'm trying to like reconcile like why gravity is part of the fundamental forces, but it doesn't have an opposing force like the others.
Yeah, I mean, like, so the fundamental reason why this is the case is roughly because gravity is described by a spin 2 field rather than a spin 1 field. And at least mathematically that's the case. If you have a spin 2 field, then you don't have like your charge doesn't come with negatives. There's only positive charges. But beyond that, it's not really the same kind of object as far as we can tell as the other forces. So perhaps it's a misnomer to categorize it into the same things. Thank you for sending 5 subs, Philip.
Oh, cool.
Or no, that's Cointel Pro. Cointel Pro, thank you for sending the 5 subs. That's huge. Yeah, so that's roughly the idea.
Okay. Well, I'm just a layman, so it's just something I'm playing around with. Actually, I'm an author, so I had to come up with some kind of something that sounded possible.
Sure.
And that was in 2006, and I've been digging on it ever since. So thank you for your time.
Of course, Jerry. Thanks for being here. And thanks for the sub.
Yep.
Very wholesome. All right, I'm going to answer some more questions. Actually, there is somebody that I'm meant to be joining the live of doubling size every 10 billion years. Yes. So it was expanding much, much faster in the early universe. And then it slowed down. But yeah, it's doubling size roughly every 10 billion years. Yep, I'm supposed to go join Mihai George. So actually, I'm going to end the live here. So everybody who's watching on YouTube, thanks for being here. And I will catch you guys tomorrow. Thanks for watching. Take care.